Hello everyone, welcome back to my YouTube channel. This is Sir DL and welcome to the Aliens Blog and Math Tutorial. For today, we are going to talk about chi-square 2 variable. We are going to discuss chi-square 2 variable. What are the objectives of this lesson? Number one, discuss chi-square. Number one, discuss chi-square. Number two, solve for the value of chi-square. Solve for the value of chi-square. And number three, apply chi-square to variable in the field of research. Apply chi-square to variable in the field of research. Always remember, try until you succeed. Please do not lose hope. Try until you succeed, and please do not lose hope. What is two-variable chi-square? It is similar to test of correlation in that it measures the strength of associations between variables. It is similar to test of correlation in that it measures the strength of associations between variables. Also, it is also known as the test of independence. It is also known as the test of independence. Example, determine if there is a significant difference in the frequencies with which males come from small, medium, or large cities as contrasted with females. Again, determine if there is a significant difference in the frequencies with which males come from small, medium, or large cities as contrasted with females. The two variables we are considering here are hometown size, which are small, medium, large, and gender, which are male and female, or male or female. The two variables we are considering here are hometown size, such as small, medium, large, and gender, such as male or female. What is the formula for chi-square 2 variable? Chi-square is equal to the summation of the square of the difference of O minus E over E. Chi-square is equal to the square of the summation of the difference of O minus E over E, where O is the observed frequency and E is the expected frequency. O is the observed frequency and E is the expected frequency. Degree of freedom is equal to the quantity of the difference of C minus 1 and the quantity of the difference of R minus 1, where C is the number of categories or levels of the independent variable, and R is the number of rows or levels of the seconded variable. R is the number of rows or levels of the seconded variable. Let's now try to apply this one, or try to apply chi-square on this given example. Frequency with which males and females come from small, medium, and large cities. For female, there are 10 who came from small cities or city, 14 medium city, 6 large city. For male, there are 4 small city, 1 male came from medium city, and 1 came from large city. We have 36 total respondents. Now, how do we apply, or how do we solve, and how do we interpret chi-square? Okay, the first step, state the null hypothesis. Let's now try to apply chi-square on the given example. Number one step, state the null hypothesis. What is the null hypothesis? There is no significant difference in the frequencies with which males come from small, medium, or large towns as compared with females. There is no significant difference in the frequencies which males come from small, medium, or large towns as compared with females. Set the alpha level, that is 0.05 or 5% or 95% level of confidence. The next one, let's calculate the value of the chi-square. How do we calculate the value of the chi-square? So given again, the first step in calculating the value of the chi-square, list all the values for the observed frequency. We will be listing all the values for the observed frequency. For females, there are 10 from small, 14 from medium, 6 from large. For males, there are 4 from small city, 1 from medium city, and 1 from large city. First step, List all the values for the observed frequency. That is the first step. As simple as that. Second step, find the value of the expected frequency. Find the value of the expected frequency. There is a different way on how to find the expected frequency of the chi-square 2 variable. How? How do we get the expected frequency? Expected frequency is equal to column total multiplied by row total over the grand total. Column total multiplied by row total over the grand total. Let's have an example. From 10, what is the column total of 10? What is the column total of 10? We have 14. What is the row total of 10? That is 30. What is the grand total? 36. Therefore, the expected frequency of the female respondents who came from small city is 14 multiplied by 30 over 36. Again, what is the column total of the female who came from small city and what is the row total? Because that will be helping us in order for us to find the expected frequency. The column total of 10 is 14 and the row total of 10 is 30 and the grand total is 36. Then we will be having the product of 14 multiplied by 30 divided by 36. What is 14 multiplied by 30 divided by 36? You can do that on your calculator. 14 multiplied by 30 divided by 36. The answer is 11.667. So the outcome or the observed frequency is 10. And on this part, we have 11.667. The expected frequency of the females who came from the large city or small city is 11.667. Next, let's now move on 14. Those females who came from medium city, what is the column total? The column total is 15 and the row total is 30 and the grand total is 36. Again, the column total of 14 is 15 and the row total of 14 is 30. We will be multiplying 15 and 30 divided by 36. 15 multiplied by 30 divided by 36. The answer is 12.500. We will be putting here 12.500. Next, let's now move on females who came from large city. That is 6. What is the column total of 6? We have 7. Very good. What is the row total of 6? That is 30. And the grand total is always 36 on this given example. Therefore, we will be multiplying 7, the column total of 6, by 30, which is the row total of 6. 7 multiplied by 30 divided by 36. 7 multiplied by 30 divided by 36. And the answer is 5.833. 5.833. Next one. We will now be moving on the male who came from small city. What is the column total of 4? We have 14 and the row total of 4 is 6. That's why we will be multiplying 14, the column total of 4, by the row total of 4, that is 6. 14 multiplied by 6 divided by the grand total, which is 36, and the answer is 2.333. 2.333. Next one, on this part, what is the column total of those males who came from medium city? We have 15 and the row total of 1 is 6. Then grand total is 36. Therefore, we will be finding the product of 15 and 6. 15 multiplied by 6 divided by 36. The answer is 2.500. The answer is 2.500. The last one, those male who came from large city. That is, what is the column total of 1? We have 7. And the row total of 1 is 6 divided by the grand total. That is 7 multiplied by 6 divided by the grand total. And the answer is 1.167. 1.167. Okay, the expected frequency is now complete. We have all of these frequencies already. Let's now move on the next process. Our next process is to find the value of the square of the difference of O minus E over E. The square of the difference of O minus E over E. O minus E, 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 O minus E. Then square it. Square the difference, then divided by the expected frequency. Let's have an example for this part. Let's now solve this one. 10 minus 11.666, the quantity of 10 minus 11.6667 raised to 2 over 11.667. 10 minus 11.667, that is negative 1.667. That is negative 1.667 squared over 11.667. We will now be looking for the square of negative 1.667. Multiply negative 1.667 by negative 1.667. Multiply the number by itself, and that becomes 2.778889. 2.778889 divided by 11.667. The answer is 0.238. 0.238. Next one, 14. The quantity of 14 minus 12.5 squared over 12.5. What is 14 minus 12.5? Okay, very good. 1.5. Well, 14 minus 12.5 is 1.5. What is the square of 1.5? 1.5 multiplied by 1.5, that is 2.25. 1.5 multiplied by 1.5, that is 2.25 divided by 12.5. Divided by 12.5. And the answer is 0.180. 0.180. Let's now move on the next one. The quantity of 6 minus 5.833 squared or raised to 2 over 5.833. What is 6 minus 5.833? The answer is 0.167. The answer is 0.167. What is the square of 0.167? What is the square of 0.167? That is 0.027889. 0.027889 divided by 5.833. The answer is 0.005. 0.005. Next one, the square of the quantity of 4 minus 2.333 over 2.333. It is the expected frequency. 4 is the observed frequency. What is 4 minus 2.333? The answer is 1.667. 1.667. What is the square of 1.667? That is 2.778889. 2.778889 divided by 2.333. That is 1.191. 1.191. Next one, the square of the quantity of 1 minus 2.500 over 2.500. First step, 1 minus 2.500. The answer is negative 1.50. Negative 1.50. What is the square of the quantity of negative 1.50? That is negative 1.50 multiplied by negative 1.50. The answer is 2.25. Negative 1.50 times negative 1.50, 2.25 divided by 2.500, the answer is 0.900. 0.900. The last one on this part, 1 minus the quantity of 1 minus 1.167 raised to 2 over 1.167. 1 minus 1.167, that is negative 0.167. Then negative 0.167 multiplied by itself, that is 0.027889 divided by 1.167. The answer is 0.024. Okay? That is the square of the difference of O minus E over E based from the observed frequency and the expected frequency. Let's now move on the next process. Find the value of x squared by simply finding the value of the summation of the square of the difference of O minus E over E. Those are 0.238, 0.180, 0.005, 1.191, 0.900, 0.024. We will just be adding all these values. That is 0.238 plus 0.180 plus 0.005 plus 1.191 plus 0.900 plus 0.024. The value of the chi-square is 2.538. The value of the chi-square is 2.538. The value of the chi-square is 2.538. The last step, write the decision rule for rejecting the null. Write the decision rule for rejecting the null. We will be using the degree of freedom is equal to the quantity of C minus 1 multiplied by R minus 1. df is equal to 3 minus 1, then the quantity of multiplied by the quantity of 2 minus 1. 3 minus 1 is 2. 2 minus 1 is 1. Therefore, our degree of freedom is equal to 2. You move on or you go to the table value for the chi-square and look for the degree of freedom of 2 and 0.05, 0.05 or 5% margin of error or alpha level. And you will be looking for, and you will be finding the value for the critical value that we need. And the critical value of 2 on the given table is 5.991. Again, the critical value for on the table, if you will be looking at the table, that is 5.991. How do we reject null hypothesis? We reject null hypothesis or H sub 0 if the value of the chi-square is greater than or equal to the critical value, which is 5.991. We will be accepting the null if the value of the chi-square is less than 5.991, which is our critical value. Therefore, since our x squared or chi-square is 2.538 is less than 5.991, which is the critical value based on the degree of freedom 2 and alpha level of 5% or 0.05, therefore, we failed to reject the null hypothesis because 2.538 or the chi-square value is less than 5.991 or the critical value. We will be or we failed to reject the null hypothesis. Therefore, there is no significant difference in the frequencies with which males come from small, medium, or large towns as compared with females. That means hometown size is not dependent of gender. That is how we reject and accept null. That is how we make decision rule for rejecting the null. I hope you understood the process in solving for the chi-square 2 variable. Okay, we are now finished with our tutorial. Everyone, students, always remember mathematics will always remind us that in every problem, there is a solution. Keep trusting, keep moving forward, keep fighting, keep looking for solutions to your problems. Always remember, choose to be happy. Life is too short. Thank you for watching and God bless you all.